It begins as a faint glimmer beyond the reach of our instruments, a speck lost in the darkness that envelops all things. At first it seems ordinary, another piece of interstellar debris wandering through the void, carried along by cosmic tides, older than the Earth itself. But then, something unusual happens. Its movement defies the expected, its shape contradicts the familiar, and its silence, the absolute stillness of its journey, begins to whisper a question that unsettles the scientific mind. What if it is not a rock at all? The story of interstellar visitors, mysterious travelers that pass through our solar system from distant stars, has always been told with a tone of awe and perhaps quiet disbelief. For centuries, astronomers imagined them but never saw one. Then, in the year 2017, a strange object appeared. It was named Oumuamua, a word in Hawaiian meaning a messenger that reaches out from the distant past. It came unexpectedly, gliding through the solar system with impossible grace, as if aware of its observers. Its elongated shape, its lack of a visible tail, and its inexplicable acceleration as it departed left astronomers in stunned confusion. For most, it was simply an oddity, a cosmic fluke to be catalogued and forgotten. But for one man, it was something else entirely. A clue, perhaps, a sign, or even a message. His name is Avi Loeb. A boy once fascinated by the night sky over Israel, a student who excelled in the discipline of physics, a mind drawn toward the deepest questions about our place in the universe. Today he stands at the helm of Harvard's Department of Astrophysics, where the known and the unknown often intersect in uncomfortable ways. To his colleagues, he is brilliant, persistent, and daring, sometimes too daring. To the public, he has become something else, a man unafraid to ask if we might have already been visited by technology not born of this earth. It was Loeb who looked at Oumuamua and said aloud what others only whispered. The object's strange motion, its reflective surface, its absence of cometary outgassing. Could these not be signs of something designed, not formed? Could it be a fragment of alien technology, perhaps a light sail drifting through the stars long after its creators were gone? The suggestion stirred both excitement and unease. Scientists are trained to doubt, to challenge, to dissect every claim until only truth remains. Yet, as Loeb's hypothesis took root, something deeper emerged. A confrontation, not with aliens, but with the limits of human imagination itself. For a while, the sky fell silent again. Then, 2 years later, another interstellar object appeared, the comet Borisov, discovered by the Russian amateur astronomer Gennady Borisov. This time its nature was clear. It was icy, luminous, leaving a trail that betrayed its chemical heritage. A visitor, yes, but a familiar one. No controversy followed. And yet the question lingered. If such objects pass through our system more often than we thought, what else might have gone unnoticed in the centuries before our telescopes learned to see? Now, in the summer of 2025, that question has returned with the force of revelation. A third interstellar body, catalogued as 3IATS by the Atlas Telescope Network in Chile, has entered our solar system. It moves along the plane of the planets, its speed astonishing, its trajectory impossibly aligned to sweep past Mars, Venus, and, in a near miss, Earth. Astronomers watched with urgency, scrambling to record every flicker of light, and among them, once again, Avi Loeb. He was among the first to announce that this new traveler displayed 6 indicators that, in his view, could point toward artificial origin. To some, these are coincidences. To others, signs. Its motion through the solar plane, its unusual brightness, and the faint, comet-like halo that seems to conceal more than it reveals, all of it invites interpretation. Could it be mimicking natural behavior to disguise its true nature? Loeb does not claim certainty. He never says, it is. He only asks, what if? And that question is more powerful than any answer. Each time we peer into the depths of the cosmos, we hope to understand more about the mechanics of creation: stars, dust, gravity, time. But sometimes we encounter something that forces us to turn that gaze inward, to confront what belief means in the language of science. This is not about faith or fantasy. It is about the edge of human curiosity, where reason meets wonder. Somewhere between the orbits of Mars and Venus, the new interstellar object continues its silent passage. It does not respond, does not slow, does not change. The telescopes record, the models compute, and in the quiet hum of Harvard's observatory, Avi Loeb and his team watch the data unfold. They know that soon it will pass beyond reach, leaving behind nothing but traces of its path and an echo of questions unanswered. But before it goes, they will look as no one has looked before. Because if even one fragment of Loeb's idea is true, if even one of these visitors is not merely a rock, then everything we know about life in the universe will change forever. And perhaps that is why we keep watching. Wait for next to continue. When Oumuamua was first detected on October 19, 2017, by the Pan-STARRS telescope in Hawaii, it appeared, at first, as an unremarkable point of light, but almost immediately, its orbit betrayed its origin. It was moving too fast, roughly 87 kilometers per second relative to the Sun, far exceeding the escape velocity of the solar system. The realization came like a quiet shiver through the astronomical community. This was not one of ours. This was the first confirmed interstellar object ever observed. For generations, scientists had speculated about such visitors, but none had ever been seen. And now, here it was, a slender tumbling fragment from another star system, a messenger from the unknown. At first, the excitement was purely scientific. Its orbit, elongated and hyperbolic, told of an origin beyond the outermost edges of the Oort cloud. Its brightness fluctuated in a way that suggested a peculiar shape, perhaps 10 times longer than it was wide, a form unseen among the hundreds of millions of known asteroids. Yet even stranger was what it lacked. No coma, no tail, no visible sign of outgassing that could explain its odd acceleration as it receded from the Sun. According to the laws of celestial mechanics, it should have slowed down. Instead, it did not. Something, somehow, seemed to push it gently outward. Most astronomers proposed simple explanations: hidden jets of vapor, fragments of frozen hydrogen or nitrogen sublimating invisibly. But none of these models fit perfectly. It was Avi Loeb who asked the question few dared to voice. Could Oumuamua be a piece of extraterrestrial technology? Perhaps a fragment of a light sail, a thin reflective craft designed to travel between the stars. In Loeb's eyes, this was not fantasy, but a logical possibility. If civilizations exist elsewhere, if they have mastered propulsion driven by starlight, then debris from such technology might drift through interstellar space, just as remnants of our spacecraft will one day do. The idea sent tremors through academia. Many of Loeb's peers rejected it outright, arguing that extraordinary claims require extraordinary evidence. Yet Loeb's argument was subtle. He did not insist that Oumuamua was artificial. He simply said that the data did not rule it out, and in science, the refusal to consider the possible can be as limiting as the rush to believe. For Loeb, the event became a symbol of how humanity approaches the unknown, whether with open curiosity or cautious denial. Then, in the year 2019, the discovery of the second interstellar visitor briefly shifted the spotlight. Gennady Borisov, using his homemade telescope in Crimea, identified a glowing body that clearly displayed the coma and tail of a comet. This was comforting. It reaffirmed the familiar. Comet Borisov behaved as expected, a natural wanderer from another system. It was beautiful, but it did not challenge our understanding. Oumuamua remained an outlier, a question left unresolved. Years passed. Loeb continued his research at Harvard, expanding his studies into what he called the Galileo Project, an initiative designed to systematically search for extraterrestrial artifacts, whether in space, on Earth, or hidden in the data archives of past astronomical surveys. He assembled a team of physicists, engineers, and astronomers, determined to approach the topic with scientific rigor rather than speculation. The project drew both admiration and criticism, but it stood as a testament to his persistence. The belief that if interstellar objects are crossing our solar system, then some may hold clues to other civilizations. That persistence was rewarded, or perhaps tested, once again on July 1st, 2025. The Atlas network of robotic telescopes in Chile detected a new object entering the solar system from the direction of the constellation Carina. Its motion immediately caught attention. Like Oumuamua and Borisov before it, its path was hyperbolic, confirming its interstellar origin. But this time, astronomers saw it early, as it was still approaching. They named it 3IATS, the third known interstellar object, a visitor from the deep galactic void. For the first time, humanity had the chance to study such an object before it made its closest approach to the Sun. Observatories across the world turned their instruments toward it. The Very Large Telescope in the Atacama Desert, the Hubble Space Telescope, the James Webb Space Telescope, and even the orbiting probes near Mars. The data began to pour in. Its velocity was extraordinary, nearly 65 kilometers per second, faster than any natural asteroid of comparable size. It followed a trajectory lying almost perfectly within the plane of the solar system, a statistical rarity, as though it had chosen its path deliberately to pass near multiple planets. It was this alignment that captured Avi Loeb's attention first. He noted that the object's course allowed close encounters with Mars, then Venus, and finally a near passage by Earth, before exiting toward the outer planets. If this were a spacecraft, he said in one of his public briefings, it could be performing gravitational assists, using the planet's gravity to alter its speed and direction, the same technique we use to send our probes into deep space. It was a provocative statement, not an assertion, but an invitation to look closer. As the object neared Mars in early October, probes orbiting the red planet caught glimpses of it, faint reflections gliding across the dark background. To many, it looked unremarkable, a body perhaps a few hundred meters wide, surrounded by a thin cloud of gas resembling the tail of a comet. Yet there was something off. Typical comets, when heated by the sun, release jets of gas that alter their trajectory slightly. This one did not. Despite its apparent vapor halo, its course remained steady, as if the outgassing were an illusion, a disguise. The question arose again. Could it be imitating a comet's appearance to conceal something more intricate beneath? Loeb compiled 6 observations that, in his view, warranted deeper scrutiny. First, the high entry velocity suggested it was propelled or ejected rather than drifting freely. Second, its orientation within the ecliptic plane was improbable for a random interstellar body. Third, its brightness varied in a rhythm inconsistent with tumbling but consistent with controlled rotation. Fourth, The presence of a gaseous envelope without corresponding changes in motion contradicted natural models of sublimation. Fifth, its interaction with solar radiation pressure hinted at an exceptionally low density, perhaps consistent with a thin, artificial structure. And sixth, the sequence of planetary flybys matched, astonishingly, the kind of path a mission planner might design to explore the inner solar system before departure. Each of these points could be explained naturally or not. The debate reignited instantly. Some argued for exotic ices that sublimate invisibly, others for fractal dust aggregates or mirror-like surfaces of frozen carbon monoxide. But even among skeptics, there was a recognition that something about this object did not fit comfortably within existing categories. For Loeb, that was enough. When data disagree with expectation, he wrote, nature is either teaching us new physics or revealing new technology. The media inevitably turned the event into a spectacle. Headlines asked if a second Oumuamua was visiting Earth, if aliens were once again at our doorstep. Loeb appeared in interviews not as a sensationalist, but as a scientist urging open-mindedness. Science, he said, is not a belief system. It is a process of learning from evidence. The universe does not care about our prejudices. Behind his calm demeanor was the same curiosity that had guided him since childhood, the desire to see beyond what others call impossible. Meanwhile, astronomers prepared to capture every possible measurement. Radar stations, optical telescopes, and infrared sensors tracked the visitor's movement. The European Space Agency's ExoMars Trace gas orbiter, circling Mars, managed to photograph its faint outline as it passed. Spectroscopic analysis hinted at materials unlike ordinary silicate or carbonaceous asteroids, perhaps a metallic mixture, reflective yet oddly featureless. On Earth, data flowed to research centers in Cambridge, Pasadena, and Geneva, where teams raced to model the object's composition and dynamics. As weeks passed, the object grew brighter, then dimmed again as it swept past the sun in late October. Its behavior confounded expectations. The gaseous shroud expanded, yet there was no measurable deviation in its orbit. This meant that either the gas was being emitted evenly in all directions, an improbable feat for a natural body, or it was not gas at all. Some speculated that the coma might be a layer of reflective dust intentionally released to disguise thermal signatures. Such an idea, while speculative, was consistent with Loeb's hypothesis that an advanced probe could camouflage itself to appear ordinary. Still, the scientific community remained divided. For every argument in favor of artificiality, there were counter-arguments grounded in physics. Perhaps it was a chunk of solid nitrogen ice from a dying planet, or a fragment of an interstellar comet core composed of exotic compounds. Perhaps its alignment was coincidence, its steadiness a result of unique mass distribution. Yet, as Loeb pointed out, probability matters. When coincidences multiply, he said during a Harvard colloquium, we must ask whether they are coincidences at all. By November, as the object made its closest approach to Earth, a safe but frustratingly sunward trajectory that placed it between our planet and the glare of the sun, it became nearly invisible to ground-based observatories. Only space telescopes could follow it now. Loeb's team coordinated with NASA's Solar and Heliospheric Observatory to gather final measurements. The data showed faint traces of polarized light, suggesting smooth surfaces, perhaps even planar geometry. Theories multiplied. Was it a shard of a larger vessel, a derelict sail, or simply a wafer of rock weathered into strangeness by cosmic radiation? Then came the most haunting detail. As it receded from the inner solar system, instead of slowing precisely according to gravitational prediction, it once again exhibited a subtle residual acceleration, too small to indicate propulsion, too persistent to ignore. The same anomaly that marked Oumuamua reappeared. For Loeb, this was confirmation that such behavior might define a class of interstellar objects, not isolated accidents. He summarized his conclusion in one sentence that reverberated through conferences and debates alike. We may be witnessing the technology of another civilization, long gone but still moving through space as silent evidence that we are not alone. Whether this statement will withstand the test of time is uncertain. In science, bold ideas often begin as heresy. But what distinguishes Loeb's approach is his insistence on measurable inquiry. He proposed future missions, rapid response spacecraft that could intercept such visitors within weeks of detection. Already, plans are underway to maintain a standby interceptor in solar orbit, ready to launch the moment another interstellar object is spotted. Humanity, for the first time, is preparing not merely to observe, but to meet these cosmic strangers face to face. The discovery of the third interstellar object marks more than an astronomical milestone. It is a philosophical turning point. Each of these travelers, Oumuamua, Borisov, and now 3IATS, reminds us that our solar system is not an isolated island. Streams of material and perhaps more flow between the stars. Among them may lie the relics of civilizations as ancient as the galaxy itself. Whether they are alive, extinct, or entirely different from anything we imagine does not diminish the wonder of the search. And in that search stands Avi Loeb, controversial, persistent, deeply human, watching the faint light of a visitor fade into the dark and refusing to let the question die. Wait for next to continue. To understand the magnitude of what Avi Loeb represents in the modern scientific landscape, one must look back to the roots of his journey, a story that begins far from the glass domes of Harvard and the gleaming mirrors of space telescopes. He was born in Israel, in a small community where the night sky unfolded with unpolluted brilliance, and where curiosity was not a pastime but a necessity of survival. From childhood, he was captivated by the silent order of the cosmos, the rhythm of celestial motion, the serenity of patterns hidden in the dark. While others dreamed of ordinary careers, Loeb dreamed of understanding why there is something rather than nothing. His brilliance in physics soon carried him to the heights of academia, where his name became associated with precision, intellect, and a touch of rebellion. By the time he completed his doctorate and moved to the United States, his focus had already expanded beyond equations. He wanted to see the grand tapestry, to connect mathematics with meaning. At Harvard, his work in theoretical astrophysics earned him the chairmanship of one of the most respected departments in the world. His research spanned the early formation of galaxies, the birth of black holes, and the possibility of life beyond Earth. But it was in the mystery of Oumuamua that Loeb found not just a puzzle to solve, but a calling, a question that could redefine humanity's place in the cosmic hierarchy. Loeb's character is that of a scientist unafraid of solitude. Many of his peers admire his intellect but hesitate to follow him into what some consider speculative territory. Yet he remains unfazed. Science, he often says, advances by ignoring authority. When he proposed that Oumuamua might be artificial, he was not seeking fame. He was, in his own words, following the evidence wherever it led, even if it led to discomfort. To him, the greater danger lies not in believing too much, but in refusing to look. The history of astronomy itself is a story of disbelief overcome, from the Earth's motion around the sun to the discovery of galaxies beyond our own. Each breakthrough began with an outlier, a voice that said, "Perhaps we are mistaken." After the arrival of the third interstellar object in 2025, Loeb became a central figure not only in the study of interstellar phenomena, but also in the broader philosophical dialogue about what it means to be human in a potentially inhabited universe. His Galileo project, once viewed with skepticism, gained momentum. More researchers joined, not to chase fantasies, but to construct instruments capable of distinguishing the extraordinary from the ordinary. New telescopes designed to capture high-resolution spectra of fast-moving objects were funded through collaborations between universities and private foundations. Small satellites, equipped with adaptive optics, began scanning the skies for faint glints, the signature of something engineered rather than eroded. Parallel to these efforts, Loeb pursued another thread of inquiry that bordered on adventure. Years before the Atlas discovery, he had analyzed records of unusual meteors that entered Earth's atmosphere at hypervelocity. One such object, detected in 2014, struck the air above the Pacific Ocean at speeds beyond what is gravitationally possible within our solar system. Loeb hypothesized that it too was interstellar. He secured funding, chartered a research vessel, and led an expedition to the crash site in the Indian Ocean. Using magnetic sleds dragged along the seabed 3 kilometers deep, his team recovered dozens of minute metallic spheres, remnants of something that had survived entry. Laboratory analysis revealed alloys unknown to terrestrial manufacture, containing elements fused in ratios not found in Earth's crust. To Loeb, this was not proof, but a signpost. "The universe," he said, "is speaking in fragments. It is up to us to learn its language." In the years since, the spheres have been studied at length. Some scientists remain unconvinced, attributing their composition to rare natural processes. Others see them as tantalizing hints of extraterrestrial engineering. The debate continues, but what matters is that the discussion itself exists, that the line between astronomy and astrobiology is no longer guarded by silence. Loeb's insistence on open inquiry has inspired a new generation of physicists who see no shame in wondering aloud whether we are alone. Technically, Loeb's vision extends beyond philosophy. He advocates for readiness, a framework that would allow humanity to intercept the next interstellar visitor before it escapes into the void. He has proposed placing an interceptor spacecraft in solar orbit, equipped with adaptive propulsion, waiting like a sentinel. The moment a new interstellar object is detected, the craft would accelerate along a collision course, gathering images and data at close range. The concept is now under study by international agencies. For the first time, the human species is preparing not merely to observe the unknown, but to meet it. This is, in essence, the beginning of a new era of exploration, not outward to planets we know, but toward objects that have come to us from elsewhere. And yet, beyond the instruments and the equations, there is something deeply poetic about Loeb's quest. He does not speak of aliens as conquerors or gods, but as witnesses of the same universal story, civilizations that may have risen and fallen long before our species took its first breath. When he speculates that the objects crossing our solar system might be fragments of ancient technology, he does not imagine fleets or battleships, but quiet relics adrift in time, carrying the echoes of extinct minds. "If Oumuamua was a message," he once said, "perhaps it was not sent to us, but simply through us, a whisper that the universe does not end with our imagination." The public often misreads this humility as certainty. In truth, Loeb never claims to know. He merely insists that we must ask. The strength of his position lies not in declaring discovery, but in challenging complacency. His detractors see risk in blurring the boundary between science and speculation. His supporters see courage in testing that boundary. Both are right, and perhaps that is precisely why his work endures. As the third interstellar object continues its journey beyond Jupiter's orbit, fading into the cold, data streams continue to arrive, tiny variations in its reflected light, small deviations in its predicted path, strange polarization patterns, all of them fuel for analysis, for hope, for wonder. No single piece of evidence may ever resolve the mystery, but taken together, they mark the dawn of a discipline, interstellar archaeology, a science of searching for technological relics older than humanity itself. The telescope, after all, is not just a lens. It is a mirror that reflects our desire to understand ourselves. Each time humanity discovers something inexplicable, it reveals its own restlessness, that deep, ancient hunger to connect across the void. Loeb's pursuit is not about aliens. It is about the continuation of that hunger, the refusal to accept isolation as destiny. In this sense, he belongs to a lineage of dreamers, Galileo, Kepler, Newton, who dared to look up and see motion where others saw stillness. The night sky above Harvard's observatory remains much the same as it was when Loeb first stared upward as a child. The stars shimmer indifferently, the planets trace their endless ellipses, and somewhere, far beyond sight, the remnants of forgotten civilizations drift in silence. Perhaps one of them once looked upon its own night sky and wondered if there was anyone else. Perhaps they sent a fragment, not expecting an answer. And now, across the gulf of centuries, it passes by our sun, carrying a question we are only beginning to understand. When historians of science look back upon this age, they may remember Avi Loeb not as the man who proved the existence of extraterrestrial intelligence, but as the man who reminded us that asking the question is itself an act of discovery. Because to ask is to admit that the universe might be greater than we imagine, that we, for all our instruments and knowledge, are still the children of a small world, listening for whispers from the stars. And perhaps one day, when another object enters our skies, the fourth, the fifth, or the 10th, we will be ready. Ready not just with telescopes, but with humility. Ready to meet what may come, not as strangers, but as participants in a story far older than the earth itself. Until then, the watchers continue their vigil, the telescopes turn, and Avi Loeb's question remains suspended in the dark. What if, among the countless fragments wandering through the cosmos, one of them remembers us?